hello. It is me, Kyle, and I'm here to learn about the Unreal Engine 4. I've done some learning already, and today we have we've already started a tutorial on the Unreal Engine website. It's, I don't know what it's called, I guess just the first person tutorial or shooter tutorial, and we are on part 3, continuing from the last stream. So I guess so far what we have is, this is our other map that we were testing on. So let me bring up FPS maps. I think I meant to call it FPS map instead of maps, but let's see. Okay. So we have a character that spawns in the middle here. And we're going to be playing in FPS mode, I guess. So first person. But we don't have the S part of FPS yet. Basically, we just have the character and the character's model in with it. And we can look around and stuff like that. And we have our little hands here. And there's a button I can press, F8, I believe. So this is our character. Just a T-pose model right now, and that's basically like either the third-person model, or it will also be the like if other characters were in this game, other players that is, and they were to view your character, they would have a model to look at. So in first person, actually, this model is hidden from the character. We've done that, I think it was like part 2 of the tutorial. And we also added these little sets of hands, and the camera for the character. Let's see if we can select it. Maybe not. Oh wait, yes. There's the FPS camera component. I don't think we can see where it is right now. No, we can't see where it is. But yeah, we have basically a capsule component with a mesh. So basically, we have capsule collision, if you know what that is, and our static mesh doesn't have collision on it because we're using the capsule. But we use that for the visuals. And then in front of the well, it's more like on top of the our little third person model, like right around here, I would say is the FPS camera component. So that way we're not like inside of our own character. And that's why if basically if we were to position the camera like right above, like right here, that's why we see the arms in the camera's view. And that's what this component is, the FPS mesh. Basically, that's the mesh that we'll see in first person mode. That's why we called it that. And we also have the character movement controller. Well, it's called a component, but it does all the movement logic for characters so they can walk around and step on things and jump. And what is this one again? Oh, it's just for allowing inputs from the keyboard and mouse to be input into this actor. So if we were to resume, we can look around. So far, we can jump. We had to figure out how to walk forward in the camera's direction, because normally if you would press W, you'd walk one way, but if you turn your camera, you would still walk in that direction. So we have to make sure when we press W to go forward, that we always are walking forward. And we also have jump assigned to the spacebar, so we can jump on these blocks here. you know, very basic platforming tools, I guess. One problem that we do have right now is when you look down in the ground, your camera's direction isn't handled very well. So since we try to move in the direction of the camera when we press forward, we don't really go anywhere. You can see if we're walking, we walk pretty quickly. But if you're looking down, you move a lot slower. And as you look all the way down, you stop moving completely. So I have D pressed all the way down, but we're not moving at all. We're moving very, very slightly. Like, you can see pixels starting to disappear in the bottom. But that's how slowly we're moving. Right and left work fine, but just forward and back do not work out well. It's really slow. So, I tried to figure out how to fix that problem. I couldn't really fix it there, so I just left it there. It's not really important for the tutorial, I guess. So that's what we have so far. Now, part 3 of the tutorial is called Implementing Projectiles. So now the S part of the FPS is right now, I guess. We'll start doing this right now. So this is the intended output where they're shooting. I guess, are these just squares that they're shooting? Or cubes, rather. And we still don't have a proper position for our arms yet. They're not rigged yet. Or the rigging hasn't changed yet. So by the end of this section of the tutorial, we'll be able to add projectiles to the game, implement shooting, set up projectile collision and lifetime, and we can get our projectiles to interact with the world and add crosshairs to your viewport. Oh yeah, there's crosshairs there too. Okay, let's start. Adding projectiles to your game. Now that we've set up our character, it's time to implement a projectile weapon so that when we fire, a simple grenade-like projectile will shoot from the center of the screen and fly until it collides with the world. During this step, we're going to add input and create a new code class for our projectile. So let's add the fire action mapping. In the edit menu, click on project settings. That's not the right one. Project settings. Under the engine heading, here it is. Look for the input. And we're going to go into the action section. And what do we want to call it? We're going to call it fire. Fire. And we want left mouse button. That's pretty obvious. Okay. So that looks right. I have zoom in from a different tutorial, so ignore that for now. Adding a projectile class. So we can close this project settings and move on. Okay, now we have to add a C++ class. So we'll just go to the file menu and click new C++ class, and the choose parent class menu will open. So we'll go and click on actor for just a general actor for this game, and we'll create that. And we're going to name it FPS Projectile. Pretty standard. Alright, so we want to add a uSphere component once that code compiles. So to basically just, wait for Unity, or not Unity, Unreal Engine to stop or finish compiling and doing a hot reload of all the game's assets. This is the one thing about the code thing that kind of sucks, is that you have to wait for the compilation to finish and stuff like that, and it takes a long time usually. Whereas like if you're using blueprints, the compile time is like a second maybe for simple blueprints. I haven't got to like a very complicated blueprint that would take longer, so it seems really easy to use blueprints since it just is so quick in comparison to code. I think I want to, right now I'm using Unreal Engine 4.15.3, I think. For some reason, my launcher downloaded that version a couple weeks ago. It was like last week, I think. So started using that, but then I just realized like yesterday that they're on version 4.18.1. So I don't know why it just did not download the right version. So I think after this stream, I'm going to download 4.18 and start using that from now on. But I want to make sure I finish this tutorial because I don't know if I can convert my project. I tried to do it last time. I guess earlier today, actually, I tried. And it just still opened up with version 4.15 instead of 4.18. So I have to look into that further to see if it needs to be converted for some reason or in some way, or if I'm just not opening up correctly. So I have a feeling this hot reload isn't going to work. Every time I have to make a new class, the first time I have to do it when I open the game, or when I open the engine editor, it like fails for some reason. But every time after that, it works fine. But this is just taking a long time, so I don't think something's working right. We can see that it made the files because they're in our project browser. Oh, I think it finished. Okay, it didn't fail that time. Hallelujah. So now we have a bunch of files open. We can get rid of those. Let's have character open since that's our current project. But we have FPS projectile.cpp. So let's head to the header file. And yes, David, this is live. We're doing it live. So there may be mistakes that I make. Just let me know if I make any mistakes. So we're going to add a reference in the header file. And for this uSphere component that we're going to make as our little grenade projectile type thing. And so I'm just going to call it the collision component. And we're going to put on a uProperty tag. Visible default. And the category is a projectile. I wonder where that is taken into account. I'm not familiar with those tags. Alright, so there's a sphere component. Now, this is basically all we've added onto the header file. The rest is auto-generated stuff. Alright, let's head over to the CPP file. And, so we want to add some code to the constructor right here. This is for the collision component stuff, or the uSphere component, rather. We're going to be setting the collision component. So we're going to use a sphere as a simple collision component because it makes sense to make a projectile out of spheres representation. So we're going to use a inherited variable here, collision component, and we're going to set that to let's see. Oh, not inherited. What am I thinking? It's the one we just created, the sphere component that we just created. So we're going to set it here as a default sub object of this actor. U-sphere. Gotta warm up my hands. My typing is a little uneven right now. Alright, so now we've set it and we gave it the name sphere component, which we'll be able to see in the world outliner once we place the actor or the projectile in the game. Although we won't be placing it, it'll be placed by the game code since we're going to be shooting it. Now we have to select the collision radius, so it's actually projectile size, not the default is like, I don't know, it's like 50 centimeters or something like that. That'd be way too big. Sphere radius. So we're going to set it to, is that 15 centimeters? It's still pretty big. Huh. Seems like it'd be a big sphere. Alright, so we're going to set the root component to be the collision component. So, we'll use root component, which is an inherited variable, and set it to our sphere that we've set up right now. So now that's basically the base component of our projectile actor. And the tutorial says you're making collision component a root component since the simulation will drive it. Okay. Now the source file should look like this. Basically all of this is added. The rest is just auto-generated. And that matches what we have over here. Alright. So now adding a projectile movement component. Locate the FPS projectile class header file in the Solution Explorer and open FPS projectile.h. I mean, that's already open. I don't know why it's telling us that. So we're going to add another little member over here. So this is going to be the projectile movement component. Again, we're going to slap some tags on it. So this one we'll be able to edit anywhere. That's why. Or not edit anywhere, but we can see it anywhere, I guess. Not sure what that means. We've used the edit anywhere tag before, which has allowed us to either edit it in code or in the Unreal Editor or the Blueprint Editor. That's a very useful tag. Not sure what or how it differs from visible anywhere. You would think it would be already visible. So it was these kind of things that I wish the tutorial on the Unreal website explained a little bit better. So there's a class UProjectile movement component, I guess, that we can just use for our own purposes here. That makes things really easy. Rather than having to code our own logic for projectiles, we'll just use the already implemented movement component for projectiles. So, step 3, FPS projectile.h should now look like the following. Yep, just that was added. Okay, let's move on. Locate the FPS projectile CPP file. So we got that. Add the following lines of code to the FPS projectile constructor in FPS projectile.cpp. So underneath this, we're going to put in the projectiles setup use this component to drive the projectile's movement. Alright, and there's a whole bunch of stuff over here. I'm gonna scoot this out a bit. Setting up my windows, and that's good. Projectile, did I spell it right? Is that the right thing? Double check if I project. I did not spell that right. Okay, there we go. Now that's correct. So I'm just gonna copy this right away. So just like we've done for the sphere component above, we're gonna make this a default sub-object of the actor. Give the name. What name are we going to give it? Projectile movement component. It's pretty easy. Okay. I'll paste that name back in. Set updated component. Set updated component. I'm not sure what this does, so let's look into it. Put this down. Alright. So we have set updated component. So let's peek updated component. I would think it would mean that if like collision component does something, like collides with something, then projectile movement component would be notified of that. I'm assuming that's what it means. It's basically like an event listener. That's gonna be my guess. Updated component. The component we move and update. If this is null at startup and auto register update component is true, the ownings actor root component will automatically be set as our updated component at startup. Okay, so no, I kind of had it wrong. So basically, the projectile movement component yeah, so it just has a internal storage for the thing that we want to move. So since it's the sphere component that we want to move throughout the world after we shoot, we set the updated component to that thing. It's pretty simple. It's just some weird terminology with that set updated component call. Anyways, moving on. We have an initial speed we can set. We're set to 3,000. Assuming that's 3,000 centimeters per second. Then we have max speed of 3,000. Next we have a Boolean variable. Rotation follows velocity. So does that mean like the component spirals or something like that? Follows velocity. Huh. We're going to set it to true. Let's take a closer look at this. So, if rotation follows velocity is true, this projectile will have its rotation updated each frame to match the direction of its velocity. Okay. So, basically, if you were to think of the projectile as like a cone, maybe, and it had like an arc to it, it would always make sure that the tip of the cone, the pointy end, would always be facing the direction it's going, so that it always looks like it's, you know, doing its most like aerodynamic path, you know, and that nose is always pointing where it's going. When I explain it like that, kind of makes sense, and it seems very obvious. But again, the wording on that just, to me, it just was not obvious. And then true. Now this is pretty obvious. The projectile is going to bounce when it hits the ground. I'm assuming there's a certain degree at which if it hits the surface, it might not bounce. Well, looks like the next property we're setting, the bounciness, might have something to do with that. You know, if it's like dead onto a wall, then it might not bounce with a low bounciness value. Percentage is a percentage of velocity maintained after the bounce in the direction of the normal impact. Coefficient of restitution. Okay. So we can have a purely elastic collision, meaning that, is that elastic? Yeah. Where all the speed is basically saved, and it just bounces at the normal of impact. This is basically like the perpendicular. Is it the perpendicular? I don't know. No, it wouldn't be. It's just, you know, basically a reflection. You know, like if you were to light a laser on a mirror, the reflecting laser direction would be the normal of impact. Anyways, so yeah, 1 is most bouncy, 0 is no bounce. Okay. So step 6. We now have 2 things basically in our constructor. That is correct. There we go. All right, setting the projectile's initial velocity. So locate the FPS projectile class header file. All right, and now we're gonna add a function. So let me add that right below tick and above our properties. So this is a function that initializes the projectile's velocity in the shoot direction given. Initializes. So it's going to be a void, and it's going to be called fire in direction. All right, and it says this function will be responsible for launching the projectile. So FPS projectile.h should now look like this. Basically, this stuff auto-generated. The 3 things down here, we've just added that up to now at least. Locate the FPS projectile CPP file right over here. Let me just save that. And add the following definition to the function we've just declared. again, I guess not again, but to point out, when you're doing coding, especially in a project-like setting, which a game is pretty much always going to be a project-like setting because it's so complicated that you can't have like a simple project. Well, not project, but a simple, I don't know what I'm trying to say, like a code base. You can have a simple code base with a game. You know, it's basically a big project. You know, I've got like so many different, different files, you know, for actors and classes that this is just like tutorial stuff. You know, in a full game, they're gonna have all these different actors in the game, all this game logic running, and extra files to handle that game logic. That when you're actually doing the actual coding and stuff like that, it's really important to have good coding standards, which also includes having good comments in your files. And while the comments that the tutorial includes, like the one we just put above our function, are pretty well descriptive. Did I spell something wrong again, or is that just that's Visual Studio just being a little slow on the uptake? So while they are descriptive, they've also failed to, I guess, document a description of like the parameters that are used. Also, if it were have like a return type, it would be important to point that out. Because if I was a person that was using this FPS projectile file, but I didn't write it, I wouldn't necessarily know what shoot direction does without having to look at the code. But since we have access to comments, it would be better to put in a comment that would maybe look something like this. You know, at param ind omega. We'd have at param because there's a thing that can parse our code and make it look pretty, but that's not important right now. But we'd have like this would be like in, so maybe like in, so that means the data for this parameter is going to come into the function, and then we put the name of the actual parameter. So that means we have to pass in data into shoot direction, which since it's an f vector, you might say an f vector that denotes the direction to shoot, well, let's say to fire the projectile in world coordinate. So that if someone that didn't know what the fire in direction, or what is defined in the fire direction code, fire in direction function, they can just look at the comment and say, okay, well, I need to use this function and I need to pass in some data, and it's called shoot direction, and it's an f vector that denotes the direction to fire the projectile in world coordinates. So as basically a user of this code, I can know that, okay, so I need to make an f vector that is in world coordinates. So I can't do like a relative vector. You know, it needs to be in world coordinates. So like the rotation needs to be correct. So that gives a bit more of a description to the function itself and how it's used for people that aren't familiar with it. You can see as I hover over the tick function, which is written by the engine, they have a similar formatting for their comment. You can see that they say at param delta seconds, which is where we've placed delta time. And it says game time elapsed during last frame modified by the time dilation. So it's very good coding practice to describe your parameters and make sure that the function's comment has basically everything that an API user would need to know. That's kind of like if you're trying to get into some more serious coding, which I think game development is kind of more of a serious game, not serious game, but serious code development work. All right, back to the tutorial. We're on step 5. So we have the projectile. And we're going to set the velocity. So we're going to take the shoot direction that's passed in, and we're simply just going to multiply it by our speed. Alright, that is pretty simple enough. So you only needed to supply a launch direction because the projectile speed is defined by projectile movement component. Alright, so now we've added 2 things to our constructor basically. The rest we've left alone for now, and we've added a new function, fire in direction. Moving on, we have binding the fire input action. So we made a fire action in the game, or the editor, in the project settings. So we need to actually use that that mapping, the controller mapping. So let's head to the header file for FPS character. Did I do this correctly? This is for projectile, yeah. Just want to make sure I put the code in the right place. Now we're moving on to FPS character, and we're going to put in the function for fire. Fire. Pretty straightforward. Alright, so just a refresher on what we've done to our FPS character. We have the auto-generated stuff above here. Then we have move forward, which is also move backwards, and move right, and does the left as well. Then we have jumping and stop jumping. Now we've added firing, and we have the camera component on here. We also have the FPS mesh, which is the hands and arms you see in the first person camera. So let's move on to the CPP file for FPS character, and we're going to add in the binding for our input. So it's an action, so I'm going to put it next to our other actions for jumping. Use a function bind action, and I named our mapping fire, and we want to actually call the function, the bound function, when we press the fire button, not when we release it. And the function we are going to use is fire. So now we have to define the fire function down below. So the tutorial is going to have us define the fire function as empty. This will be interesting. I'm gonna set it up like that. Interesting. So I wonder how that works. Alright, so to define the projectile's spawn location. When spawning the FPS projectile actor, there are 2 points to consider when implementing the onFire function. Namely, where to spawn the projectile or the projectile's class. This is so the FPS character and its derived blueprint know what projectile to spawn. You're going to make a camera space offset vector. What the heck is that? A camera space offset vector to determine the projectile's spawn location. You'll make this parameter editable so that you can set and tweak it in your blueprint. Ultimately, you'll be able to calculate an initial location for the projectile based on this data. Alright. So you'll be able to calculate initial location for the projectile based on this data. Okay. So, let's go to fps_character.h, head over to the header file, and we are going to add a property. So gun muzzles offset from the camera location. I'm going to slap some uProperty tags on here. You think it's better to use the static mesh socket on the gun? Well, right now we don't have a gun. So, I mean, yeah, it's probably easiest because you know exactly where that is going to be. And if you have different guns, it's obviously going to be a different location. But it's a tutorial, so we don't even have a gun yet. We just have some hands. Let me show you where we're at. So right now, we just have this going on. Just the old straight arms, locked in position. You can move around. Camera works okay. We can jump. But yeah, we haven't changed the positioning of the rigging for the arms yet. And let me just show you. We can't see our body. We turned that off in the tutorial, and we do have a T-pose model that is given to us. That's all we have for now. I'm pretty sure we add a gun later on, so maybe in the end we'll end up changing that so we have something to work on, but right now we're just trying to use the projectiles and make something happen. It's a very basic that we can do. So the tag we're gonna put on here is edit anywhere. Read right. Blueprints to use that. Category. Category. Typing is hard. So it's going to be an F vector. It's going to call it muzzle offset. Alright, yeah, anywhere it does that. The blueprint editor within details tab. The blueprint read write specifier allows you to get and set the value of the muzzle offset within a blueprint. Okay. And then we go more in the header. And what is this? Another property. So we'll put this right below here. The projectile class to spawn. So edit defaults only. I still haven't learned what that one is yet. I'm not sure what they mean by defaults. I've seen that terminology used before. I think it was, where was it used for? Like we were adding a custom variable that we could edit somewhere. It had like a header, or like a title of defaults. So something to do with that. I'm just not sure yet. at least the tutorial finally tells us what it is. And I'll get onto that. But now we have a subclass of this is our projectile, I guess. So yeah. PS. I'm like seeing things. I thought I spelled that wrong. Turned out okay. So now we will have knowledge of our projectile that we just defined. Well, I guess the class that we defined is now in here. Now we just need to tell it which instance to put that in. I guess we'll maybe do it in the blueprint. Maybe it's hinting at. So the edit defaults only specifier means that you will only be able to set the projectile class as a default on the blueprint, not on each instance of the blueprint. Okay. So does that mean you won't be able to change it if you have multiple different versions on in the game, I guess? Like basically you won't be able to edit it after the fact. Huh. I guess we'll see how that turns out in the end. So now our header file has 2 more properties put on. Now let's compile. So I will go and do that. Oh, we're just checking for build errors. So let's check that output. And what's next? 3.2 implementing shooting. During this step, we're going to implement the fire function so that our character can start firing projectiles. Implementing the fire function. Locate the FPS character CPP and include the following. Include. Still waiting on that build. First one of the night, so it might take a while. Looks fine. Oh. Always wonder what that is, but that's nothing, I think. Let's create a library. Okay. No errors. We are good. So our include is for the FPS projectile. Now that we've made it in our, we've actually have a member in our FPS character of FPS projectile. So might as well include that so we can use the fire. So we're just gonna go all the way to the bottom and put it in here, I guess. Yeah, fill in the definition finally. So we just have fire and direction. That's all this does, I guess. And oh, FPS character does a whole bunch of stuff in here. So starting from the top, attempt to fire a projectile. So, if the projectile class does actually exist, then we will start by getting the camera transform in the form of a F vector and a F rotator. So we want to get both location and rotation. So F vector, F rotator, camera rotation. All right. So now we can call get actor eyes viewpoint. Eyes viewpoint. Okay. can pass in those variables in there, starting with the F vector, if I can spell it correctly. I think my main problem is actually typing, not spelling. Although sometimes it is spelling. I just plain forget how to spell things for a few seconds. So now we want to transform muzzle offset from camera space to world space. All right. I think I may have to review my vector math notes from college. It's gonna be probably gonna be really valuable while I guess while learning how to do all this stuff again. All this different math stuffs. It's all good stuffs. So the muzzle location, we're gonna offset it. Like, oh, there we go again. Location. Just cannot type. So we're using the F transform of our camera rotation to transform muzzle offset. So let me look at this. So we're passing a reference of muzzle offset to transform vector. So basically we're using camera rotation as a base in order to change muzzle offset so that we can get exactly what this comment says, transform muzzle offset from camera space to world space. Take off Firefox so you can see what's going on here. So we have the F vector muzzle location. So we're going to take the location okay, so again, using the camera's rotation, we can call transform vector on muzzle offset so that since we have a vector for muzzle offset, but it's relative, we can use the rotation in order to turn that relative vector into a world coordinates or world space vector and slap that on top of the camera's world space location. So now we get the world space, the muzzle's world space location in muzzle location. Okay. Then after that, we have the muzzle's rotation. We're going to be using a rotator for this. That's much easier since we're already in world space. We can just go from there to world space. It is matching. It's not like we have a different rotation based on our camera. So we want to skew the aim to be slightly upwards. Basically, we're trying to create some kind of grenade launcher type weapon. So we're gonna use the pitch to increase our angle. To create that kind of lob effect. Now we're gonna store the whole world in a variable. I've never seen this before. And I feel like I want to know what this is. I don't know what that is. What is a U world? What kind of things does a U world have? The world is an object. Okay, let me read this. The world is the top-level object representing a map or a sandbox in which actors and components will exist and be rendered. A world can be a single persistent level with an optional list of streaming levels that are loaded and unloaded via volumes and blueprint functions, or it can be a collection of levels organized with a world composition. In a standalone game, generally only a single world exists except during seamless area transitions when both a destination and current world exists. In the editor, many worlds exist, the level being edited, each PIE instance or play-in editor instance, each editor tool which has an interactive rendered viewport, and many more. Okay, so it's just the world map is somehow stored. We have things like layers, active group actors, thumbnail info, the persistent level as a class, a whole bunch of stuff that makes the level work, basically. Interesting. So now we want to double check to make sure that the world exists, and we were able to get the world. Then we want to do some spawning. So we have a class F actor spawn parameters, we call it spawn params. Now we want to set the owner of the spawn params owner to this character. So let's just get into it. This stuff is all pretty new to me. Apparently we have an instigator. And we're just going to set it to instigator, because that makes sense. I have no idea what the instigator is. And it is a pawn responsible for damage caused by this actor. Okay. I guess that's a pretty good name for it. So I'm assuming all pawns. No. Actor. Well, no. Wait. It says pawn responsible, so actors can't cause damage. Okay. I think that's what it's trying to tell me. Interesting. But actors can be damaged. Okay. Okay. I just wouldn't have thought that pawns can only cause damage. Alright. Bring back Firefox. So where was I? I was down here. We have the instigator. So then we want to spawn the projectile at the muzzle. So we have a pointer to the FPS projectile, our custom class. And we're going to set it to a whole bunch of crap. Holy crap, what is this? So we're going to access our world. We're going to call spawn actor. So we're actually spawning the projectile in the game out of our muzzle. Now that we have all the data we need, it's all ready. So we have the class that we've, well, not yet. We haven't set yet, but we will set later as a default, I think, or something like that. So what does a spawn actor call need? It's got a few definitions. So it can take spawn parameters. Huh. Spawn parameters. No. Okay, so the core parameter that we need to send in is at least actor spawn parameters. But we're usually gonna send in some location rotation data. Okay. Or we could place in a class we can use it as a template. Right, that's why we have this. So we are spawning a projectile and we give it the projectile class specifically. Then we have to give it the location and rotation. All right. Just wrapping my brain around this. So now we have our offset muzzle location and we have the rotation of the muzzle prepared. So we pass those two in. And then we also pass in at the end the spawn params that we've created in this if statement. So that's all set over here. Is there anything else to this? Yes, there is. So if you're successful doing that, I assume, then we will set the projectile's initial trajectory. So we're going to set up a vector for that. So it makes sense to base it on the actual rotation of the muzzle that we already have filled in. Oh, I didn't know you could do that. Hey, Lewis. Yeah, it helps that I actually have background knowledge in C++ and programming, so it's very easy for me to jump into it. I know that, of course, a lot of people don't have background in programming and C++, so it's a lot easier to get the blueprints, but there are benefits for both, definitely. Thankfully, the Unreal Engine website has some pretty decent tutorials on code projects, even for those who may not be familiar with C++. So now that we've set up the vector for launch direction, we can call the projectile movement component function. Basically the whole reason why we set up that different class. Alright. So now we have a bunch of stuff in FPS character. We also have a debug message in there. We are using FPS character. We can see that when we start the game. We have all of our bindings. We have all of our actual input functions right here. A lot of logic in comparison for fire, but it all makes sense. Lewis says, I started a simple FPS project too. I'm a Java developer and I'm trying to learn C++ as well. Yeah, I started Java in high school. I had a class in there. I didn't take it any further than that class really, but it pretty much set me on a good path for learning more languages during college. So yeah, it's not that hard once you learn one language, even like Java, to learn C++. Just different syntaxes and looks differently, but especially for C++, the same concepts are all there. I've also been following a lot of different tutorials, so far I was able to implement an inventory system. Okay, that's pretty cool. And Raycast in C++. Nice. The only other experience I have with some game development was in Unity. I was following some tutorials in there. And they had a pretty cool tutorial with it was like a top-down shooter. And that was pretty cool to see. Basically how they turned something like that into the game's code, even though it's like still in 3D. It looks kind of 2D in the way that you handle it, but you still need to work in like 3D space. I kind of opened my eyes to how complicated things can be. Okay, everything builds successfully. All right, now it says, well, Indie Omega says, C++ isn't really needed on Unreal. Yeah, blueprints can do a lot, but it's nice to have the ability to write some code in C++ and then turn it into a blueprint module, so you can port it into different classes really easily in the blueprints. So I think the best is going to be a combination of both. That's what I think is going to end up being pretty good. I tried Unity for a while, but I think for FPS games, Unreal seems better. Yeah, I feel like overall, the Unreal Engine has more of a handle on the whole game engine aspect. So before continuing, download and extract the projectile mesh. Okay, now I have to do this again. Thankfully, it's not big. I mean, it's just a sphere. Why did they do that to me? Anyways. I mean, it's good that both, like, well, Unity, Unreal Engine, and I think the CryEngine also, they're free to use, for hobbyists. So, either way you take it, it's always a good place to learn because, it's free. You don't have to invest any money into it. So, that's really helpful. Place in there, then I'll go into projects. Sorry, I'm doing some folder manipulation so I can import the stuff. Content. Okay. Assets. There we go. Okay, now our projectile mesh is all ready to be imported. Can I? No, I have to go into the content, I think. Yes, import to game. Let's get rid of this. So we have our sphere.fbx, which will have all of our stuff. Do we need to do anything with it? No. It just wants us to import it as is. And it tells me to also ignore this warning. So we will. We want to save everything so that we have it in our project. All right. Navigate back to the blueprints folder in the content browser. Click the add new button and select blueprint class. Expand the all classes drop down menu and type FPS projectile into the search box. All right, let's do that. Well, We have blueprints in there. You know what? Let's just put into assets. This is my catch-all folder, so add new blueprint class, and we want to do all classes and search for our FPS projectile. I think after this this tutorial, it is a long tutorial, but once I do finish it, I think I'm gonna try to look into some. I didn't mean to do that. I'm gonna try to look into some blueprint tutorials so I can get a better grasp on blueprints. I'm interested to see how flexible they are and how powerful they can be, if they can be. Definitely want to look into that. So let's open that up. I like having that ready. Oh, I guess we have to do that again. Thank you. Click on collision component in the components tab. Maybe. I'm trying to figure out. Let's just move this over here for now. Collision component. And then click on the add component drop down list. And select static mesh. We'll name it projectile mesh component. So scroll down to the static mesh section of the details tab and click on the drop down menu that says none. So here we are. And now just select sphere. Not quite sure why we needed a separate static mesh. We can't just use the starter content meshes. So note that if you're making a multiplayer game, you also need to uncheck initial velocity in local space in the movement component in order for this projectile to replicate correctly over a server. Huh. Is that where the... I'll uncheck this. So you'll need to uncheck this if you're doing multiplayer. Weird. Okay. It's kind of a weird note to make. Anyways, so let's go back to the mesh component and set the XYZ scale values to 9%. All right. Clicking the lock icon on all three axes. Clicking the lock icon locks all three axes so that they preserve their relative scale. Sure, we'll lock it down. Set the projectile mesh component collision presets value to no collision. Collision presets. Is that up here? I look in the right place. Projectile mesh component collision presets. And it was no collision. Since you're using the sphere component, which is the root component for collision, and not this static mesh. Okay. Compile and save. Done. Assuming we're done with the details for now. Open. Okay. So double click on the FPS character. Now I have to figure out where I put the character now. Did I put that in the actual blueprints folder? No. No. That was top level, wasn't it? Yep. Alright. Wait, it wanted me to be in that mode, didn't it? Oh, where's that button that switches modes? It's around here somewhere, isn't it? Wait. No. No. Wait. I don't know what class defaults mode is. We'll get the projectile class. Gameplay, actor take projectile. Does it just mean this? Is this what it means? I guess we'll set it. So hopefully that's the correct version. Oh wait. No? That's what I thought I was looking for, but it actually was not. That's defaults. I don't think this has ever actually done anything. Maybe I don't have the help files installed. Class defaults mode. Well, we'll just say this is good, right? That's good. I think oh, you didn't see that. Yeah, I set the projectile to the blueprint that we just made. Hopefully that means class defaults, whatever that means. Set the muzzle property, muzzle offset property to 100x. So that will spawn the projectile slightly in front of the camera relative to the camera. Compile and save. Compile, save. All right. So let's hope I've done everything correct. And now we can do it. We can play it. Yep, seems to work. I don't think it hits stuff yet. It'll go through stuff, but it's got physics in the world. It does stuff. Okay, we made progress. All right. .3 setting up projectile collision and lifetime. Currently, our projectiles live forever. They never disappear from the scene outliner and don't collide with other objects in the world. During this step, we're going to set up a projectile collision and lifetime. So, limiting the projectile's lifespan. Head over to Visual Studio and locate the FPS projectile CPP. So, let's add this to the constructor. Die after 3 seconds. All right, it's pretty self-explanatory. Editing the projectile's collision settings. The Unreal Engine comes packaged with several preset collision channels, or channels. However, the engine also provides customizable channels that game projects can use. Open the project settings. And select collision to customize a collision channel. Under the engine tab. All right, what's going on here? So select new object channel. Right here, yes. You can have up to 18 custom channels, including object and trace channels. This is list of object type for your project. If you delete the object type that has been used by game, it will go back to world static. Sure. Okay, so we're going to name this projectile. And default response is set to block. Sure, we'll accept that. Select new under preset. What just happened? Block. Edit channel. Select new under. Did I miss something? Under preset. And name. What the heck is preset? Oh, here's preset. Found it. So we're going to click on new. And name your new profile projectile as well. Refer to the following image to set your collision presets. Collision enabled. Query and physics. Projectile. And we'll just name it our projectile collision profile. So we have collision responses, none. We want to block visibility, camera, world static, world dynamic, but we want to overlap upon. But block physics body, vehicle, destructible, and projectile. Okay. So this collision profile specifies that the projectile will be blocked by static actors, dynamic actors, actors simulating physics, vehicles, and destructible actors. Also, this collision profile specifies that the projectile overlaps pawns. But doesn't it also mean that if two projectiles were to hit each other, that they would block each other? Is that intended? Alright, anyways, using the new collision channels settings. Locate the FPS projectile class CPP. So head over to Visual Studio. And in the projectile, add this to the constructor. Well, you know, let's put it next to the actual collision component setup. So we have the body instance of the collision component. I don't know what that is. And then we set the collision profile name to projectile, which we just set up. Okay. So now our projectiles will follow that profile. That makes complete sense. That's pretty cool. You can set up collision profiles. So now we have the header file, or not the header file, the source file, the CPP file. Looks a lot like this, mostly constructor stuff, and one small actual, I guess, logic function down here. So we'll save this. It's already saved, and we will build it. Let's make sure we don't have any errors. I'm pretty sure unless I type something just completely wrong, we've done it all correctly. So 3.4, getting projectiles to interact with the world. Now that we can detect the projectiles' collision interactions, we can determine how to respond to those collisions. Build turned out okay. So during this step, we'll add an on-hit function to FPS projectile that'll respond to collision events, getting projectiles to react to collisions. So head over to the projectile header file, and we're going to add on a function. So this function is gonna be called when the projectile hits something, and we're gonna call it on hit, as we read in the description of the step. And it's gonna have some parameters in it, but first let's put on the ufunction tag. So it's going to allow any primitive component to be passed in. So I'm assuming that's the component that the projectile has hit. Wait. Then there's other actor. What is that? So the build was successful. We can minimize that. All right. Other actor, and then another primitive component, other component, hit component. Is this the component of the projectile? I mean, if it is, it'd just be the sphere component always, because that's the only thing we have a collision on. I think. Then there's the other actor here, and the other component. So I guess the component on the other actor. Then we have the normal impulse, and an F hit result class is returned. Wait, not returned. Passed in, I guess. Wait, that's a result though. I don't know what that means. We'll figure it out. So let's continue defining this. This function prototype. New primitive component. Affected normal impulse and constant F hit vector reference hit. So now we have the header file with, what is this, 3 properties? No, 2 properties and 2 functions. And that matches what we have here. Except I spelled sphere wrong. Now it should match. Alright, locate the CPP file to add a definition. So we're going to put in the same comment that we put in the header. Normally, on my own projects, I would just stick to either putting the comment in either the CPP file or the header file, so that I don't have to edit a comment in both places if I were to change the function. That just seems like a better, well, easier coding practice to follow than putting it in both locations. Normally, I usually just put in the header file. I just stick to that. I'm just going to copy this because it's a pretty long set of arguments. sure you get rid of that semicolon. If you do that, then we have. We're gonna check to make sure that the other actor is not ourselves. I'm not sure how that would happen. I guess if the game's collision detection were to fail and the projectile hit itself, then that might fire. Otherwise, we want to make sure that the other component is simulating physics. Interesting. I think a lot of things are interesting. I'm easily interested. So we're gonna actually cause things to move with our projectiles. Interesting. With the add impulse at location function. So we're using the velocity of the actual projectile and increasing it by 100 for that's the impulse vector. And we also give it the location at which to apply the impulse at, which we have from the hit result. You can see right over here. Let me just move that in the way. See what's going on. What's going on over here? Okay, that's pretty cool. So in the constructor, we're going to add, what is this? On component hit, add dynamic. So I'm going to add on a event listener, basically. For collision component, so let's go back to the constructor. That doesn't make any sense. What's going on here? On component hit. Have I done this right? On component hit dot add. Huh. So we have add, which will add a function delegate to this multicast delegates invocation list. Add unique as a function delegate to this multicast delegates invocation list if a delegate with a same signature doesn't already exist in the invocation list. And then there's internal add dynamic. Let's just take a look at this. Why isn't the add dynamic visible? So add dynamic, internal add dynamic. What the heck? What's going on here? So we have binds a UObject instance and a UObject method address to this multicast delegate. So we have the UObject instance would be this according to the tutorial. Then we have an in method pointer, which is the on hit function we just defined. And also an optional, I'm assuming that's optional, right? No, it's asking for what? It is actually asking for a function name. That doesn't seem to be optional. And then it says, note, do not call this function directly. So we won't. Instead call add dynamic, which is what the tutorial shows, which is a macro proxy function that automatically sets the function name string for the caller. Huh. Hey there, I don't know how to say your name, but I recognize you, alright? I acknowledge you. Welcome. I'm just in the middle of being confused. That just does the same thing, it's just unique. Huh. This is interesting. Should we look this up? Unreal Engine. Add dynamic. That's not how you spell dynamic. I cannot type. Sounds like a lot of people can't get add dynamic to work. So we have here. I am wondering if the add dynamic function is still in use for 4.12. Compiler says it's wrong. Function signature has been changed in 4.12. You can see in patch notes. The new signature. Add dynamic. No, they still have it on there. Weird. Oh, wait. Here we go. Let's try searching for 4.15. I think someone is following the tutorial right here. I'm trying to make an FPS game and I'm using the official, I think, FPS tutorial from the UE wiki. I made the shitty mechanic and now I'm trying to make projectiles interact with the world. I don't want explosion or anything because I just want to make them kill enemies. First I need a function that would be called whenever the projectile will hit something. I did everything they wrote in that tutorial, but I get an error. Here's an image. How can I fix this? You appear to be missing an argument in your function signature. The signature is declared as follows. Let's double check what we have. So we have a component hit signature. What is that? And then we have a U primitive component, which is what we have right here, or a pointer to a primitive component. We have a hit component. We don't have a hit component. Wait, no. Wait, I missed. I was going too fast. Okay, so primitive component pointer here. Then there's a hit component right here. No. No, it's, I don't know what I'm doing. It's broken up into names and stuff like that. So we have U primitive component pointer. And then there's a comma here. This macro is doing weird things, I think. But then we have hit component here. Then we have a actor pointer. Then other actor. U primitive component. Oh, U primitive component. Right there. Other component. They call it other COMP. Does that matter? Then we have F vector. F vector. And then normal impulse. Yes. And then const F hit result. Did I type that? Did I hit vector? So now we have F hit result there. and then finishes off with hit. This seems right now at the very least. I may have just had the wrong stuff. I don't know if like the spelling of the actual parameter matters, because in here he says so your function signature would look like this, and it has the full name in there instead of other comp. So let's just stick with putting component in there. Yeah, let's just stick with that. And now, when we come over here, oh, it has to parse files. Come on, Visual Studio. Work for me. Do this, please. All that I ask you is for IntelliSense to work. Still didn't come up. Still has add dynamic. Okay, what if I just force add dynamic on there? Maybe because it's like some weird I don't know, some weird macro. Well, now IntelliSense has popped up with something actually functional. I don't know what's wrong with this. We'll try this out. I've got my comma. This comma. Address of on hit. On hit. Okay, that seems to have worked. Yeah, I think it was just because it's a macro that IntelliSense just did not. Yeah, I mean, how could it? How could IntelliSense know that add dynamic was part of on component hit? Okay. Strange. Okay. I mean, I've seen that kind of stuff done at my work, but they did it a little bit differently. So it wasn't like in the code; it was in a definition like up here. So it's kind of specialized. But they did that kind of thing where they have a delegate stuff and they set it up elsewhere using macros. All right, that's a little bit over my head, but if it works, I guess it works then. So we're saved, and then we should build it right now. So let's verify that the projectile has been set up correctly. No typing errors, hopefully. Just kidding. F hit vector. I hit F vector again. Oh, because I copy pasted. I think I must have accidentally read result as a vector, and since I said it, I typed it out. So that should be good. And success. Alright, so let's test the projectile collision. So to do a little bit of setup for this. So let's move that a little bit further in. Alright, so after the build finishes, go back to the Unreal Editor and open this. Select the floor static mesh. Copy and paste the floor mesh. Make sure that the ratio lock is unlocked. Scale the floor mesh copy. I mean, it's a stack mesh, so we'll just put a cube in there. We'll kind of place it over here. Cube. Let me take Firefox off so we can see what's going on here. So we have this cube. Let's scale it down a little bit. How about just one notch down? Yeah, that looks fine. Just kind of make sure it's right there. We'll build the light map stuff, all the good stuff. So scroll down to the physics section. Yep, we know that needs to be rebuilt. Go do your thing. There you go. You're done now. Go away. Go down to the physics section, right down here, and check the simulate physics box. You know, let's put it more in the center, I think. Maybe something like that. There has some room to shoot it at. So save your map and double click on the FPS projectile. So this blueprint, I guess. Open class defaults mode. I think that's just this. And click on projectile and mesh component. This. Locate the collision presets property. Right down here. And select set to projectile. So this is for the projectile, so we'll compile and save those changes. And now we should be able to play it. So now we have this. Oh my god, did you see that? Is there a quick button for restart? I don't know. Wait, come back. So that works, I think. Alright, I guess we're done with that. Next. How much do we have in this one? Oh, this is the last step for part 3. So, add in crosshairs to your viewport. During this step, we'll add a crosshair HUD element to our game so that we can aim our projectiles. Importing a crosshair asset. Before getting started, download and extract this sample image. So let me just do that real quickly. Take that over into... here. Pull the crosshair out. Put that into the project. Can't see what's going on right now, but it's just I'm opening up folders. Okay, so now I put in my asset folder, so that will be available for import. So right click inside the game browsers, or the content browsers, file box to open the stuff. I'm not sure what it means by file box, so we're just going to click on this. Import the game. And import the crosshair. Locate and select the crosshair.tga image file. Click open to begin importing. Oh, I've done that. And then click the save button to save your imported image. Save. In the file menu, are adding a new HUD class. So in the file menu, new C++ class, and we want to choose HUD right here. Base class of the heads-up display. We're going to name it FPS HUD. So we're going to create that class. Locate the FPS HUD class header file in the Solution Explorer. So we have to wait a moment for that to get all finished up. Alright, that's all done. So in the header file, we don't have much to go on here, so we're going to add on a protected section. Okay, just checking the other ones. I was just noticing that they put protected on the same column as the braces. So let me just put that over there. So that's protected section. And in here we're going to say this will be drawn at the center of the screen. I'm going to add the U property tag on here. With the tag edit defaults only. And this is for a texture, a 2D texture. Crosshair texture will be its name. And now we have to also put in a function for the HUD. So this will be the primary draw call for the HUD. It's going to be an overriding function. So we say virtual and override. All right, so now we need to define that function in here. Void AFPS HUD draw HUD. I'm gonna make sure to call our parent draw HUD first. Crosshair texture. So to make sure that the crosshair texture exists. And if it does, then we're going to start by finding the center of our canvas. So I'm going to create a 2D vector called center. We're just going to do some simple math to find the center. So multiply by 50% basically to find the center of the X, and then do the same for the Y. So that should put us in the center of our canvas, and then we will offset by half of the texture's dimensions so that the center of the texture aligns with the center of the canvas. Right, because if we were just put it at the center, then I would assume that the top left portion of the texture would be placed at the center. But if we offset it, then the center of the canvas will have the center of the texture icon, basically. The center of the texture aligns with the center of the canvas. Okay. So again, we'll make a 2D vector. To hold our crosshair. So we'll grab the center's X position. And what are we going to do? So we're to grab the actual texture, get its surface width. Surface, shoot. Surface width. And then again, multiply by 50%. To get half. Then we'll do the same for the Y. This code is so long it's running off of the screen, but I am typing it just as it appears on the tutorial. Have faith. All right. So that's the positioning of the crosshair. Done. Now we need to actually draw it at that position. So we have here something called a canvas tile item. So we give it the 2D vector for the draw position. And we have to give it the resource property of the crosshair texture itself. Okay, hold on, Visual Studio, I'm working on it. Crosshair texture. I don't like this. We named this one with capital H. It doesn't need to have capital H. Crosshair can be one word. Then crosshair texture resource. And then we finish off with the setting the color to white. I'm going to look at this tile item thing. Or not tile item, canvas tile item. So we have an in position, which is the draw position. We have the texture in, and then we have the in color right here. But they forgot to actually put a comment in here for that argument, so we don't really know what in color means. Okay, sure. I wonder if that actually changes the color of the thing, or does it, like, I don't know what that means. Because on the texture itself, it's the crosshair is red, so we'll have to see if something changed with the color. but there's some kind of blend mode that we can apply on this tile item apparently. SE blend translucent. Oh, there's a whole bunch of different blends. You see that? Opaque, masked, translucent, additive, modulate, masked distance field and shadowed, translucent distance field and distance field shadowed, alpha composite, alpha blend, translucent alpha only. Holy crap. And there's an RGBA mask. Huh. Weird. I guess that means that we'll be able to see behind the HUD item, basically. So I wonder how the blending works with that RGBA blending type. Like, can you give it like a tinting color, like a blue tint to some HUD item or something like that, maybe? This music's pretty cool. I like this song. So that's that. We can build that. So I'm going to do that while I'm reading here. All right, now we can extend that CPP HUD class to a blueprint. So now that that's built, now we can extend it in here. It's already right here highlighted. So we'll create a blueprint class based on the CPP file, and we'll name it BP underscore FPS HUD. And I'm just gonna put in assets. Why not? So click create blueprint. Done that. Name it BP. Done that. So now it's open over here. You're good. Step 5, make sure your blueprint, save it. So let's just compile and save it. I don't think we need to do anything with it. Okay, so yeah, we don't need to do anything here for now. So in the edit menu, click on project settings. Under the project heading on the left side, click on maps and modes. Select Blueprint FPS HUD in the default HUD dropdown. Okay, close the project settings. Go back and open the Blueprint editor. Okay, never mind. We do need to look at that. And then click on the dropdown menu located in the FPS HUD section. Go down Firefox. So now we have the crosshair ready. Finally save the blueprint. Well, we need to compile it first. So let's compile it, then save it. So that's all good. Alright, so we gotta verify our HUD. Click the play button, and now we should be able to aim the projectiles with the crosshair. Do you see a crosshair? I don't really see a crosshair. Hold the phone. I'm just gonna compile everything again. Oh, I gotta compile my game mode too. It's just probably in content. This one. Compile. Good to go. Yeah. I think I just had to compile my game mode, mainly. I had that happen before, too. Oh, man, that thing's aggressive. So that's 3 parts done. Huh. Alright. Let's look again. So that's our crosshair. Is there like a full screen mode? Yep, there is. So that's our crosshair. But we also had what was it, like translucent blend mode on? It doesn't seem like it's like see-through at all. Those like translucencies just like give it a brightness or something. And we also did something else to it. What else did we do? Let's just look at it again. Oh yeah, linear color white. I don't notice anything white about that. It's not like it's outlined in white or anything like that. I don't quite get this. I don't quite get the HUD stuff yet. I fell off again. Alright. Well, that's that, I guess. All the code is here. Holy crap. So congratulations! You've learned how to add projectiles to your game, implement shooting, set up projectile collision and lifetime, get your projectiles to interact with the world, add crosshairs to your viewport. Let's double check to make sure that we actually did properly implement the lifetime stuff. Hold on. We got so many actors. So we have a bunch of projectiles. And they should disappear after 3 seconds. But they're still in the world outliner. We may have to go back and see what went wrong. Where was that? That was in projectile.cpp, and we had the initial lifespan. Die after 3 seconds. It did not die after 3 seconds, though. Next will be character animation. But I am starting to get tired. So that will be in a different stream. I'll start doing that. So next stream I won't... I was thinking about changing it to Unreal Engine version 4.18.1 because I'm at 4.15.3 right now. So I'll stick with this for now. I won't upgrade versions right now. I don't want anything to, I guess, be ruined with the project version changing and stuff like that. So, initial lifespan. How long this actor lives before dying? Note that this is the initial value and should not be modified once play has begun. Huh. So it should die, it just doesn't. Or maybe not in the way that I expect it to. So weird, I guess. Huh. I don't know if like the tutorial is just missing stuff. Like maybe there's a certain way to dispose those dead actors, those dead projectiles, but the very basics work out pretty well, actually. Not bad for beginner tutorial. And we're not even done yet. Alright, so that's it for today. We did a whole bunch of bunch of stuff with projectiles and shooting projectiles and hitting stuff. You know, that was a whole ton of fun. Got a crosshair now. We can shoot a box and make physics work. We added on into our ability to walk around in first person with little hands that are at the bottom of our screen, and we can jump. All right, that's progress. And I happen to notice that the shadow remains here. I don't know what that is. Don't know what that's about. The box used to be here, but it's not anymore. All right. And I think it's for a non-existent box, is it? Yeah. I have to rebuild the lighting, I think. Let's see if it fixes that. Yeah, the shadow went away. So we have a new shadow. And now it properly goes away once we shoot that box. Huh. Okay. I'd call that a successful little learning session right there. Little education-ish. Yeah, I don't know. So we did some cool things. I'm looking forward to building on top of this. So thanks for coming out. If you enjoyed this, let me know. If you want more stuff like this or you want something else from me, you know, just let me know. I'm happy to, I don't know, maybe show more of something. I downloaded Blender today to start doing some modeling work, but I'm going to go through some video tutorials on my own, so at least know the basics. But I think there is probably going to be an upcoming stream eventually in 3D modeling, so we can do some basic modeling learning there too. So soon we could probably have a basic game going soon. Can't wait for that. All right. Again, thanks. And again, let me know if you think the stream is okay. If it's all right, give me a shout out. If there's anything I need to improve on, just let me know. I'm willing to work on it. All right. Y'all have a good night or a good day or a good soon to be morning or a good midday. And have fun shooting boxes in Unreal Engine. All right. Bye.